Welcome to Chapter 2. Today, we're starting our exploration of fractions and ratios. In this section, we'll focus on fractions and proportions, fundamental concepts that appear frequently in the math section of standardized tests. Let's start with the basic concept of fractions. A fraction represents a part of a whole. It's written as a divided by b, where a is the numerator of the number of parts we have, and b is the denominator of the total number of equal parts. For example, if we have a pizza divided into 4 equal slices and we take one slice, we have 1/4 of the pizza. Similarly, if 3 out of 5 students in a class are wearing blue, we can say that 3/5 of the students are wearing blue. Fractions help us express parts of a whole in a precise mathematical way. Now let's explore proportions. A proportion is a relationship where two ratios are equal. We write it as A over B equals C over D. This means that the ratio A to B is equivalent to the ratio C to D. For example, 2/3 equals 8/12 because the ratios 2 to 3 and 8 to 12 are equivalent. We can use proportions to solve real-world problems. For instance, if 2 out of 3 students prefer math, then in a class of 12 students, we can use proportional reasoning to determine that 8 students will prefer math. Proportions are powerful tools for solving problems that involve equivalent relationships. Let's discuss strategies for solving proportion problems effectively. First, identify what the problem is asking. Carefully read the problem and determine exactly what you're solving for. Second, set up the proportion correctly. Make sure that each part aligns properly. For example, if we're comparing defective cars to total cars, both ratios should be set up in the same way. Third, use cross multiplication to solve. If A over B equals C over D, then A times D equals B times C. This powerful technique simplifies solving proportions. Finally, if you're dealing with a multiple choice question, consider plugging in the answer choices. This can sometimes be faster than solving algebraically, especially with complex proportions. These 4 strategies will help you tackle any proportion problem efficiently and accurately. Now let's put these strategies into practice with some example problems. We'll work through each one step by step so you can see how to apply these techniques to different types of proportion problems. Let's solve our first example. We have the equation 2a over b equals 1 over 2, and we need to find the ratio of b over a. First, let's use cross multiplication to solve. We multiply 2a times 2, which equals b times 1. This simplifies to 4a equals b. Now we can find the ratio b over a, which is 4a over a, which equals 4. Therefore, b over a equals 4, which corresponds to answer choice D. Let's move on to our second example. A company makes 10,000 cars and 3 out of 200 have a defect. We need to determine how many of the 10,000 cars will have defects. This is a perfect application of proportions. First, we set up the proportion. The ratio of defective cars to total cars should be the same in both cases. So we have 3 defective cars out of 200 total cars equals X defective cars out of 10,000 total cars. Next, we cross multiply. 3 times 10,000 equals 200 times X. This gives us 30,000 equals 200X. Finally, we solve for X by dividing both sides by 200. X equals 30,000 divided by 200, which equals 150. Therefore, 150 cars out of the 10,000 will have defects. Hence, the correct option is C. Notice how straightforward this problem becomes when we use proportional reasoning. Now, let's tackle a more challenging example. We have the equation 2 over x plus 1 equals x plus 1 over 2. We need to solve for x plus 1. This is a bit tricky, but we can use a clever substitution to make it easier. Step 1. Let's call x plus 1 by a new variable, a. So a equals x plus 1. This transforms our equation to 2 over a equals a over 2. Step 2. Now we can cross multiply. 2 times 2 equals a times a, which gives us 4 equals a squared. Step 3. Taking the square root of both sides, we get a equals plus or minus 2. Since a represents x plus 1, and we typically work with positive values in this context, we'll take a equals positive 2. Therefore, x plus 1 equals 2. This means x equals 1. Hence here too the correct option is C. Notice how substituting a for x plus 1 made this problem much easier to solve. Let's recap what we've covered about fractions and proportions. We've learned that fractions represent parts of a whole, written as a over b, where a is the numerator and b is the denominator. Proportions are relationships where two ratios are equal, written as a over b equals c over d. We've seen that cross multiplication is a powerful technique for solving proportion problems. Most importantly, we've practiced key strategies: identifying what the problem asks for, setting up proportions correctly, and solving them methodically. With these skills, you'll be well equipped to tackle fraction and proportion problems on standardized tests and in real-world situations. Remember, practice makes perfect. The more problems you solve, the more comfortable you'll become with these concepts. In our next lesson, we'll explore about ratio boxes, a method to solve ratio problems efficiently by organizing ratios and values in a structured format. Thank you for watching, and keep practicing these important mathematical concepts.